Good morning, everyone. I'm William Dennis, Product Manager on the Google Identity team. Part of my responsibility is looking at our open source, open standard protocols such as OAuth, OpenAI Connect, and we're always looking for ways that we can improve the usability and the security of our users who go through these flows. So I think a lot of people at this conference, and certainly our team, have spent a lot of time promoting this idea of federated sign-on. Federated sign-on is a great way that you can improve the usability, help get people into their apps faster, reduce password usage, etc. But what happens when people don't actually implement this correctly? So the following is based on a true story. I buy a new iPhone, and I want to set it up with all my apps. Of course, since I'm a Google Sign-In user, I'm going to be using Google Sign-In to set up all my apps. So let's start with the New York Times. Go to the login page, and of course I'm going to pick login with Google. And I've never used this phone before, so it's completely blank. So I need to sign into my Google account. First thing I need to do is type in my email address. Pretty familiar. Type in my password. Get my second factor verification code via SMS. Type that in. Consent to the identity permission. And hooray, I'm in the New York Times. Excellent. Not too bad. Get my second app. This time I want to sign into Stack Exchange. And of course, I'll use Google Sign-In. Why not? Let's get signed in. And wow, look at that. So easy. I'm already there. I can just tap once, and hooray, I'm signed in. All right, federated sign-in, working fantastically, reducing password use, improving my usability. Excellent. All right, now I want to link one of my Internet of Things devices, and I want to link this to my Google Calendar so that it can remind me when I have some events. Oh no, what's this? I have to sign in again? What happened? Okay, I guess I'll type in my username again. And by the way, every time I repeat an action, from now on, I'm going to be putting a duck on the screen. You can thank/blame my UI designer for this. Then I'll type in my password on the mobile device. Get another SMS, type that verification code. Oh, and this time I actually got it wrong. I got two of the numbers around the wrong way, so let's switch out to the SMS app, try and remember that code better, go back to the app I was in, type it in again. I'm going to call that half a duck. Maybe you're less clumsy than me, or maybe not. All right, finally, signed in. I can grant the permissions, and hooray. All right. Whew. Now I want to set up another calendar app, actually. And look at that, it supports Google Calendar, fantastic. This should be easy. Oh, geez, not again, right? Okay, username, password, get another SMS, type that in, and all right, finally I'm in. I guess you're getting the idea by now, but let's do it one more time just to make it as painful as possible. So third app, this is a mapping app, and again, I've got that sign in, the Google button. All right, great. But look at that, I've got to do it all over again. Phew, okay. So I just demonstrated signing into 5 apps there. The first one, there's no way around the first one. The second one was instantaneous because it was using a Chrome custom Safari view controller, and I got signed in instantly. The next 3, though, they were all using WebView, and I had to repeat that process, and it was very painful, as you saw. And while I did that, I'm not entirely sure that every user will actually do this. And the data that we look at is definitely not very good for this. So we see about 48% of people, nearly half of people, actually just abandon that when they get that WebView sign-in with no sign-in state already there. So I'd like to make the point that I think single sign-on really means that you only sign on once. Now, this may seem obvious, but people have told me in the past that actually single sign-on meant that you are using the same sign-on credentials, the single set of sign-on credentials, and you can reuse them everywhere, and that's single sign-on. Certainly, what I believe, I think the Google Identity team believes, the definition of this is really that it should be once. I should sign into my account once on the device, and I shouldn't have to repeat that again. And if there is some reason that I do have to re-authenticate, let's say I traveled and perhaps my movement looks a little bit suspicious or something, and there is that re-authentication, then at least I should only ever do that once as well. It shouldn't be per app. It should just be once. Just in case there's any confusion, single does mean only one, not of several, and I'd like to apply that to the actual sign-in event itself. not the set of credentials. Oh, and did I hear correctly that actually the host app can interact with that web view? Well, actually, yes, it can. So those last 3 apps that I signed into, that host app that was presenting that sign-in experience in a web view, had the ability to actually copy my cookie jar or inject JavaScript and like alter my sign-in flow. The host app could have done things like log my password, it could have altered the page, it could have changed the consent, it could have pretty much done whatever it wanted to do. It's fully in control of that web view. So that's pretty bad. And even in this situation where you have like a corporate IT app or a SaaS app, where you may have a pretty strong trust relationship, I still think that it's really not great. It violates the principle of least privilege to give that app a more powerful credential that it needs. And there's this risk that even though you trust the developer, you don't necessarily want to trust every single line of code that they include in their app, including from other developers. All you need is one bad third-party SDK, and your credentials could get compromised. And this is not just a theoretical risk. There was an example last year of a fairly major company that included an ad SDK in China. And that ad SDK was collecting PII and doing some really nasty things. And I'm pretty certain that this fairly high-profile brand had no intention to do that. It just wanted to make a little bit of money off the app, as a lot of people do. And it was that third-party SDK that really let them down and compromised them. And as a result, they lost trust from their users. So I would say as an enterprise, like, those are not risks that you want to take. As a developer, you don't want to take that risk either. Better to be safe, right? Like, why get that credential if you don't need it? Why have the ability to copy the user's session cookie if you don't need that? If all you need is just that lesser OAuth grant of the specific scope. So that all sounded pretty bad. The good news is, late last year, we saw the introduction of this new concept called in-app browser tabs. And this is on iOS, known as SF Safari View Controller, and on Chrome, Chrome Custom Tab on Android. These in-app browser tabs kind of merge the best of both worlds, from the web view side of things to the full browser. So like the web view, they're actually displayed within the app. The user is not getting lost. They're not like launching a different app and doing an activity in that app. They don't have the ability to change the URL bar and go and do something else, go and check their email or get lost. So they're still captive and they're still focused on that task. But it also has some of the real benefits of the browser, such as the shared cookie state. So if the user's signed in, if there's a session cookie already there, then it will be there in the in-app browser tab. And it's also a completely secure context. So unlike with the web view, the host app can't read and write cookies, and it can't inject JavaScript. So I think all these things are very attractive attributes for OAuth. And your UI designers will still like it because you're still inside the app. You're not leaving the app, which was previously the problem with using the browser. So can we use these in-app browser tabs to sign in? Well, yes, we can. Can you roll the video, please? So I've talked a lot about Google sign-in, but let's switch it up a little bit. And I'm going to show a demo here using Ping Federate. So this is a native Android app that has just launched a Chrome custom tab, and it's done an OAuth authorization request to Ping Federate. And as you can see, actually, the username was already pre-filled. So that's just, you're already seeing some of that shared session there. The username must have already been in a cookie. So the user logs in, so they've never actually logged into this IDP before. Well, at least not recently. So they log in, grant the request, and now we can make an API call. So that looks pretty normal. That's probably what would happen almost exactly in a web view anyway. So that's not that special. But let's clear out the data here just to simulate a second app being used. And let's run that same demo again. And you can see this time, the user didn't have to log in again. They were already logged in. It's just one tap. They can approve the request, get back into the app. So that's pretty cool. So that's basically single sign-on. Of course, I'd be remiss if I didn't show a Google demo. So we support this as well. Just a plain old OAuth 2 request to the custom tab. User grants the permission, and we can make the API call. And one of the cool things about this is that the app doesn't actually really know what's going on in that web view. It just opens that request and gets a response. So here we're doing a more complex chained authentication, where we actually did an OAuth 2 request to ping federate. Unbeknownst to the app, ping federate used Google as the IDP before returning that to ping fed and getting back to the app. And the app is now making an API call to ping federate here and has actually no idea that Google was involved in that transaction at all. And just for completeness, we'll run that again and see what it looks like. In this case, ping actually saved a cookie to know that Google was the user's IDP, so it didn't even show the disambiguation. And that's something that I'll talk about in a bit, is a very useful attribute. Next slide, please. So what just happened? If the user needs to log in, they log in once. Subsequent requests get SSO. The more complex chained auth scenarios work. And so here we have a sequence diagram, and we're looking at a standard IT app case. So this is an IT app where you know who the IDP is, and you only have one IDP because that's your enterprise IDP. The IT app does an OAuth 2 request in the custom tab to the enterprise's authorization server. What follows is a black box where the user gets authenticated, however their enterprise authenticates them. And finally, the authorization server returns the OAuth authorization response back to the app. Here's a slightly more complex sequence diagram for a typical SaaS setup. So this is where the SaaS app may have many, many different IDPs, many, many different tenants that the user could use to sign in. But again, the SaaS app just makes that one very standard OAuth 2 request back to the SaaS backend. What follows is then the black box happening in the browser tab. And in this case, the SaaS backend may need to work out like what tenant does the user belong to, and then authenticate them before returning that code. And one of the really nice things, again, actually, about custom tabs here is using cookies, using the shared property of that browser tab, not just for the user's authentication state, but even just remembering who their tenant is. So you could remember, oh, this particular, I know this user, they're a ping federate customer or they're a Google customer. And so we know who to redirect them to. We don't even have to ask them. We don't even have to say, like, what's your domain? Or even what's your username? The other really great thing about browser tabs is that by being actually an extension of the browser, they share many of the properties that the full system browser has. These are things that haven't been possible in WebView and are still not possible in WebView. Things like mutual TLS. Previously, if you wanted to use mutual TLS in authentication with a native app, you would need to somehow distribute that TLS certificate to every single app where you wanted to use it. And the app would actually need to understand how to use it. And it would need to probably know a little bit of business logic about who you were as an IDP. And it was all very custom, and it was all very complex. Well, as I keep saying, because the browser tab's a black box, you can sort of make that flow infinitely complex. The app is just doing one OAuth call into the browser, getting one URL response. You can do custom tabs. You can do any kind of second factor you can imagine. You can chain however many levels deep you want. Can you roll the video, please? So this is one of the really cool things, I think, that you can do in a custom tab. Here we have a native app, and we're simulating an OAuth authorization request using GitHub. The username was pre-filled there from a drop-down. That's another great property of the browser there. Chrome has a list of your usernames and could pre-fill that. And then this particular user has a U2F second factor. And the browser tab has now actually launched the authenticator intent. The user tapped that key to the back of the phone, did an NFC touch, got the second factor, and it's now returned to the app. And all that happened, and this is the best part, without that native app knowing anything at all about U2F. U2F is a very, very cool standard. It's pretty complex too. The cryptography is pretty complex. That app that didn't have to know anything. It just opened Chrome, and Chrome handled all that for us. Next slide, please. And so what's the support like of these in-app browser tabs? Well, it's actually looking pretty good. So 96% of Android devices can already run the version of Chrome that supports Chrome custom tabs. And custom tabs are available in any browser. So if you happen to be a browser manufacturer on Android, you can actually support this pattern as well. It's not only for Chrome. The iOS store is also very good and looking better every day. Now, you may be wondering, well, there were a few percentages of users there that were left out, and potentially some platforms that I haven't actually talked about yet. Well, the good news is, I think, with this pattern, that you can support all your users by using just the regular browser. So the in-app browser tab is kind of the UI optimization of this flow, and a very important and I think a very valuable optimization. But it is still just an optimization. So everything I've talked about is still valid on other platforms and for those users that are not yet on a version that can support the in-app browser tabs. We have a production example. So my team distributes the Google sign-in libraries for iOS. And that library does use Safari View Controller. So if you would like to see a production example, you can try that. Or you can look at any of the apps that integrate our modern version of that library. All right, let's talk a little bit about the implementation if you want to get your hands dirty and try this out yourself. So John Bradley, who introduced me, and myself, we're the co-authors on this draft best current practice that's currently going through the OAuth working group at the IETF. And this draft best practice kind of tries to capture everything I've talked about and sort of lay out in fairly technical terms how to do this pattern securely and safely and correctly. So a good starting point if you want to jump into the docs would be there. Basically though, an authorization server has sort of 3 requirements to support this. The first is, don't assume that a native client can actually keep a secret. This is fairly obvious, I guess, but because those apps are deployed widely, people can decompile them and extract the secrets. So a lot of people have implemented OAuth in a way that they assume it's a web server talking to them, and they assume that that web server has a secret. And that does work fine for servers. It doesn't work quite so great for apps. So that's the first thing. You might want to have a client type that is like an app client type that doesn't have some of the assumptions of your web clients. The second thing is, OAuth actually defines the redirect URI as a URI, which means that the scheme doesn't have to be HTTPS. However, a lot of people, when they implemented OAuth, they add that restriction that it has to be HTTPS. And there are certainly good reasons for doing that. But again, when it comes to supporting native apps, you might want to have that native app client type, no need for a secret perhaps, and the ability to have a custom URI scheme redirect. Of course, this pattern does work with the more modern universal links on iOS and the equivalent feature on Android. But URI schemes are still required to get that backwards compatibility. And finally, our recommendation is to support PKCE. This is a relatively new extension to OAuth, but it secures the code grant. And let me talk about that just a little bit. It basically just adds a code verifier to the original request, a hash of the code verifier, I should say, so that when the authorization server returns that authorization code, it's linked to that code verifier. And if you don't present the original code verifier when you're redeeming that code, then the authorization code is completely useless. This is very valuable when it comes to things like custom URI schemes or any kind of inter-process communication for native apps, which is typically susceptible to interception or perhaps eavesdropping. It's a very, very simple extension to OAuth. I've talked to a bunch of people that have basically added it to their servers in a day. But it's very, very much worth doing. So the 4 companies on the screen, these are the ones that I know about so far that have implemented all the 3 requirements of the best practice, and they fully support the ability to do an OAuth flow to an app in a custom tab. Please reach out to me if you add yours to this list, and I'll put you up on the next slide. When it comes to the clients, my team have done a lot of work in this area, and we developed this library which we call AppAuth. AppAuth is an open source client library for Android and for iOS that fully implements the client side of this best practice. And we actually open sourced this code and we contributed it to the Connect working group of the OpenID Foundation, and it is now a project that's managed in that open foundation environment. So if you try it out yourself and you find a bug or you have a feature that you want to improve, you can make a pull request and let us know. We can take a look at it and we'll merge it in. Already we have some great contributions, such as from Rebecca at the UMEA University, adding a dynamic client registration to the Android library. So it's very much a community effort now, and we'd love your help if you try it out. I hear that there's a few tricky things in Android getting this to work correctly, so we actually built up a fully interactive demo. We did this for I/O, but you can actually run it anytime you like. It takes about 20 minutes, and it'll show you how to fully set up OAuth for Android in your own app. You could either run it with your app and just integrate it directly, or you can try it with our sample app just to understand how it works. But it's basically better than static documentation. It's a fully interactive walkthrough of how to set this up in your apps. And I like to launch something at CIS every year, so this time, actually in 2 hours' time, that URL will contain code for a Cordova plugin that adds in-app browser tab support. So Cordova, or PhoneGap, as it's also known, is a way to build a hybrid web-native app on various platforms. And we don't want to see Cordova getting left out here and not being able to use these browser tabs. So we have this a little experimental plugin that can launch a browser tab. We don't have the full OAuth client library at the moment for this platform, but this could be basically a building block if you wanted to build that yourself, or if we ever do actually build it. Okay, so I want to talk code very briefly. This is an example integration of OAuth with iOS. What we're doing here is we're doing dynamic discovery on the issuer, pulling down their discovery document, and setting up the endpoints. Then we're doing an OAuth authorization request. Once we have that request, we perform that request, and the OAuth library is automatically working out what to do with that request. If the device has iOS 9, it will use SF Safari View Controller. Otherwise, it will drop back and it will use the mobile Safari. In Chrome, that logic is even, on Android, that logic is even a little bit more complicated. Because as I said, any browser can actually support custom tabs. So on Chrome, we first look for the default browser. If it has custom tab support, we'll use that. If the default browser doesn't have custom tab support, we'll look for any browser with custom tab support. And if that doesn't work, then we'll just fall back basically down the line, and we'll find something to handle that request. To get the OAuth authorization response back into your app, you need to declare the custom URI scheme or the universal link. This is an example of the custom URI scheme, so that you can receive that code coming back on the redirect. And a brief word on that, when you are picking that custom URI scheme, do consider a collision-resistant URI scheme, such as one based on reverse DNS notation, like com.yourcompany. There are two big advantages for this. One is that it's very unlikely someone will innocently, accidentally use your scheme. The second thing is, if someone maliciously tries to use your scheme, it's also going to kind of be a bit obvious. Like, if you're using like com.google.yourapp and you're not Google, then it's kind of going to look a little bit obvious that you were doing something wrong, and you can't sort of pretend, oh no, I was innocent, just using my scheme. So that's a recommendation for that. Finally, once you have that URI scheme registered by app, you can actually receive the OAuth redirect, and then you can make an API call. So that was, I think, 4 slides of code. Not too many lines of code. It's still a little complex, but this was actually like the low-level implementation of like kind of raw OAuth. Many of you will be using the Google sign-in library or other kind of more consumer-friendly libraries from various partners. And in a way, it'll be the responsibility of those libraries to actually do this for you. So it'll be even simpler. But if you are building an authentication system yourself, it's still only 4 slides. So I think that's pretty good. And I want to end with one final thought. I hope this is a little bit self-evident based on the introduction and all that pain that I showed you of the user sort of struggling through those sign-in flows with the various different apps, and the bad security properties that I talked about of OAuth. But given those flaws, and given that there are viable alternatives, and my team is doing our best to really help create more alternatives and give you libraries and help with that migration, don't assume that we're always going to actually support those web view flows, at least for Google as an IDP. Because clearly it's not really in the user's interests to continue doing that for much longer. So I'd say it's a good time to start reevaluating that and maybe looking at migrating. And if you're an IDP in the room, then I would hope also that actually a lot of what I said probably applies to you. And you may want to start thinking about, is that something that you actually want to continue to support? And if so, for how much longer? Given that there are such good, viable alternatives that now exist in 2016. So with that, looks like we have about 5 minutes if people have any questions. Thank you very much. At the back there. John's got the mic, I think.
IDP, is there any best practice around, like, make sure to show account chooser before you start going through the flow? Because the SSO cookies bother me a little bit.
Right. Great question. So yes, I think the best practice, if you do support multiple accounts, would be an account chooser style flow. So you can look at the example in the OpenID Foundation, the account chooser working group, I think has the canonical example of that. Google itself has an implementation of that when you're assigning to multiple accounts. And
that sometimes doesn't fundamentally limit you there.
Right, but I think from a best practice perspective,
right.
the issue is that you have to add something to your request to the IDP in the OAuth thing that says, don't honor the SSO cookie, show account chooser instead.
Right, that's true. So if people didn't quite catch the question is, if as a relying party you sort of know that the user might have a couple of different accounts and you want to make sure that they've picked the right account and they haven't just got automatically signed into whatever they were signed into previously. And that is definitely a real problem. Fortunately, I believe the OpenID Connect spec has a few really relevant parameters here. The first is the prompt parameter. So if you go prompt equals select underscore account, that is, at least in Google's implementation, that will give you the account chooser disambiguator and give the user the option to add a new account. So we definitely see that's very popular for people if their users particularly have multiple identities at Google, perhaps a consumer one and a corporate one, and they don't know who the corporation is, then that's the recommendation. If you actually know who their company is, then you can use some more advanced techniques, even like you could use login hint, for example. Google has a parameter called HD, standing for hosted domain. So if I know your AOL.com, I could go hosted domain equals AOL, and then they will refine that list to only those relevant accounts. That's not actually a standard parameter, but it's not rocket science, so anyone could do it. And actually, I would like to talk a little bit more with the community about getting some of those sort of tenant-based hints standardized if possible. Thanks for the question.
So if my understanding right, I mean, the true mobile single sign-on can be achieved only with the Safari view controller and the Chrome custom tab. But the reality is most of the enterprise SaaS app, what we have right now, are in the web view. So do you think there will be an interim solution to support that, to have a true mobile single sign-on, or do we have to still wait everyone getting into the Safari view controller or the custom Chrome tab protocol?
Right. Well, I think the great thing is if you are already using WebView, particularly if you're doing OAuth in the WebView, it's actually pretty trivial, I think, to migrate. So if the WebView is just loading a URL, which is the OAuth authorization request, and then getting that response, that's pretty much what the custom tab does, or what the Safari view controller does. There's a few differences probably in how the redirect happens, how you get the authorization code. So because you can inspect that WebView, you could redirect pretty much anywhere and just pluck that code out. That's probably going to be the more complex change. The authorization server will probably need to support those three things that I mentioned, have the ability to have a custom URI scheme redirect, just as a way of getting that code back into the app. But I think actually, if you are using WebView, you're pretty close already, because you're already doing a web-based authentication. So I don't think it's a huge stretch to go to the next level and put that in a browser tab.
Yeah, there are some sort of intermediate things like using Kerberos on iOS that you could do if you had an EMM system, but that's unlikely to be actually easier for anyone than updating the app. There isn't any general solution other than that doesn't involve some sort of update to use a more modern flow.
All right, we have 1 minute, so I'm going to have to make this one quick.
William, I was really excited to see the U2F mobile demo you did or showed. Any thoughts about when that NFC capability would be in the mobile browser, so it could be used more generically?
Good question. So the question was, when are we going to see kind of browser support of the U2F pattern, so you don't have to kick out to that extra app? I know that it's coming. I don't know exactly when. The W3C has a working group currently looking at standardizing that library, so I think that's going to help massively on all these platforms. You can expect it. I just don't know exactly when. I think we're still kind of working through some of the issues, just making sure that this is all like standardized and production ready, and yeah. All right. Well,
we should make a quick announcement because you didn't mention the masterclass tomorrow.
Yes, thank you, Andy. So if this topic interests you, actually, Andy and I are running an hour-long masterclass. So it's going to be a deep dive on the exact same topic that I've just been talking about, but really getting into the nuts and bolts. And it'll be a lot more interactive, almost no prepared notes. So come to the masterclass if you want to learn more about that. Also, I'd be remiss if I didn't mention. Sorry. I think it's first in the morning at 9:45. Also, I'd be remiss if I didn't plug the Google Masterclass later today. We'll be talking about our identity for work and our new Firebase OAuth offerings as well. So please come to that. All right. Well, looks like I'm out of time. Thank you very much. And please get in touch if you have any questions or if you have any success stories.